Okay.
So, oh, share screen. So what I've sent to Maite is basically just a bit of is a data set. But we, if necessary, what we could do is we could type it up from here. Oh, actually, that's a point. I could just use ChatGPT to get this a text file and put it into the chat potentially as well. But what I'd like to do is just for everyone to open up the IP Win2 software on their computers, and then if that email has come to you, Mighty, or no?
Yeah,
No, it's not.
it has.
Oh, it
I'm
is.
just trying to put it there in the proper place so I can share it.
Ah,
So it
perfect.
has
Okay,
arrived. Yeah, and I will
thank you.
put all the. Okay, yeah, perfect. So then let me just put it in a folder here. I can share really quick.
So,
Put
so
all
the
the
data.
documents together.
Yeah, thanks. So the data is just it was just a random data set that I pulled up. It's which has got the sort of a classic crystalline basement rock shape to it. Just to use as a preliminary example on how to use the software. So if you open up the software, you should have this sort of image of the software in your screen, and then all you need to do is click on the white button here and to add a new to add new data basically. So or you can press File and then connect new VES point. Once you've done that, you should have this screen that comes up on your computer. And once you get the data, well, if we look at this data over here, actually, what you can see from the data set is that the MN/2 is being kept at 5 meters spacing, basically. So if you remember, AB are the outer two electrodes that send out the current, and the M and N are the inner two electrodes that are measuring the voltage. So the inner two electrodes in this particular sounding that was carried out have been kept at 5 meter spacing throughout the until getting close to the end of the sounding, while the outer electrodes have been moved outwards over quite a long distance. So that means we know that immediately means that they're using a Schlumberger array. In fact, it's even on the title here. They're using a Schlumberger array to carry out this sounding. So going back to this screen, you can then click on this tab here to make sure that that is stating Schlumberger as your array system that you're going to be using with the software. Once you've, oh, sorry.
No, so sorry, the links have been shared. I'm not sure. So normally people has access to that file with the 4 little files inside.
Thank you very much.
Which one do we update? Yeah, upload. We have to upload one of them, right?
There should only be, I think there's only one there at the moment.
No, I shared all of them because you attach 4 documents. So I put all of them together in the same link.
Oh, okay. I thought I'd only sent you one. Great, that's fantastic.
You were going to send one, but I got 4, so So I'm
Okay,
like,
okay.
put all.
So which documents have you got? Because have you got the
See,
CSV
Paolo?
file.
Have you got the Paolo?
Power Hospital VES uncorrected, and the
Yeah.
VS data, and then the task select drill location from Power VES data.
Brilliant.
PowerPoint.
It came out as a fail when I thought I attached it, so that's great that it actually went through anyway. Brilliant. So has everyone got to this point in their screens where they've selected the Schlumberger array and they've got this text box in front of them?
I'm a bit lost. I was doing the other thing, so I'm a bit.
We are uploading the data now. Me and I am uploading the data.
Thank you.
Me, I'm at the stage of the screen that you are presenting now.
Excellent. Okay. What might be easier at the moment, Maite, would it be possible for you to? Can I use you as the guinea pig and ask you to share your screen with the software?
Sure, it's just I'm the one that is lost, but then people will catch up then. Is that okay?
Oh yeah. Who would like to share their screens and act as the guinea pig on this? Anyone? Any volunteer?
Me, no, because I am using the software on another computer.
I mean, I can share it. I just because you have to then just help me to catch up with where you guys are.
Yeah, Maite,
Sure.
just open, I think just go ahead, Maite. It will be fine.
Yeah.
I trust you.
Thank you. So basically, I have opened the software, but because I was trying to do the so now you just want me to upload. Do I have to do now? You
So
can see
click on
my
the
screen.
file.
Perfect.
Yeah.
No, that's perfect. So, yeah. Oh yeah. Go
That's
for it,
fine.
Oliver. Not add file. It's just if you put new VES point on there,
Oh, so okay, I'm now.
and we'll.
Yeah.
That's
Yes.
great. No, that's and
Yes,
then
Lubenger.
you can see that it's already on Schlumberger for your array grid, which is good. I think that's normally the standard. So now, if you're able to open up that, so normally, well, historically, you would have to tap in all the data from whatever photograph or report that you have for the data set. But I have to say that the AI is now enabling you just to simply place the picture into AI, and it comes out with a nice CSV file straight away. So it's saving all of that time. So if you open up, Mighty, the
Yes, I can try
CSV file.
now. Yes, I think I put it here. I just put it here. I put it here. But I guess because it's not a text file, is it?
I think it's a CSV file.
A CSV. Oh, here is only for text. So, is there any other way I can upload?
Oh yes, sorry. Yeah, if you open it up in Excel or just go straight through your folder
Yes, I
system.
might have to change it format, no, or something.
Ah, perfect. Yeah.
This is okay. I need to do same. I couldn't upload.
I was, and then command no, so the text, this one.
You could do it that way, or you could simply just copy and paste direct from the CSV file that you've already got.
Okay, yeah, like
Which,
just do like this.
except take out the top letters.
The table.
Yeah. And then copy.
MNAB. Okay.
And then.
But you see, this is the opposite, so I have to change it, right? AB, MN. I think the order of your.
Oh, is it the other way around? Is it?
I think so. Yes, MN, AB.
Oh, yeah. Right? So we'll have to swap those round. Yeah,
so
absolutely.
Just put this one. So I just copy AB. Oh,
And
it's not.
you have to press. So that's one of the obscurities with this. You have to press paste. Yeah.
Okay. Now.
It's great. It's actually very helpful. You're doing this because it's, I think so.
For MN now.
But I have everything in one column, Maite. Do you have
You
the
have
column?
everything in one column.
In the big data.
No, I have 3 columns. Yes. Have you saved it as text?
Ah, okay. I didn't do the text. I'm going to do the text before.
And then, so the value
And
that
then
I have here,
see the, yep, that's it. And that fits into the row A column on the far right.
Yeah, with the zeros.
Yeah.
Oh, well, look at it's all plotted.
And you really don't have to worry about any of the other columns in that table at all. It's those 3. So SP, self-potential, voltage, current, and K is the shape factor. But so if you were using equipment that had to calculate apparent resistivity, which is row A, using original voltage and current data, then you'd have to put a shape factor into that to get to a row A. But as it is, most equipment that you'd receive, most reports you'll read will have its apparent resistivity in as a reading. So hence we just put it in straight, direct. Yeah, Carmen.
Yes, for me it's happening that I have, when I open the Excel files, I have all this number, but just in one column. And I don't know how to change it.
That's what had happened to Aurora. Me, the only thing that I did is open it up here and then just save it as text. Did you do that?
I did it,
Yeah?
but when I open it in one column, when I change to test, it's not working.
For me, when I change to text, it's still
because
one column.
finally, in fact, I just think I just opened directly this and I just copy it. So I didn't open the one in text. That will be easier, by the way. Because if you convert it in text, what you might have to do is just to open it in text and it might understand the columns.
And which test? Because I save like the second option of test and it's not working.
If you open directly this one with Excel, just the best data, the one that was CSV. You open it, do you see one column or 3 columns?
One column.
Only with this one as well. I think it's because you have these new Windows, whatever it is, right? I have still the old one.
Me too. It is opening only one column.
You are too advanced.
If it's opening in one column, it won't be much effort to just copy unless it's somehow mixed up, to just copy and paste them separately, through that one column, I hope.
Can you share it in the chat, your document?
My document, you see, it just shared the link. You have the same link.
Okay, it will happen the same, I think, when we
but the one of Carmen.
Oh, you add, Carmen, you can, or you can share your screen, because what I think Jaren is saying, just copy up to the value that is that variable, and then you paste it within the software.
Do you want to share your screen, Carmen? And
yes,
we can...
one moment, I'm sharing. A ver.
It's difficult because it's all the information in the same cell. So
yeah.
We need time to do this. I was trying to put the file in the screenshot is possible, I can show.
Okay, so now what are you suggesting to do?
I cannot see your screen myself. I don't know if
you don't see it.
Okay, you touched it. You put it there on the chat, right?
Me, I put an screenshot.
You put an screen. Yeah, it's true.
That
ver,
is
sorry, I was not serious.
It's the comma separated one. Yeah. I mean, if you import it, it doesn't allow you? No, because it's CS. If you import it from the software itself, you see open TXT in the bottom.
No, because for example, I did, a ver, OpenTXT, I already converted. A ver. And it's not changing. But
just
maybe
to make.
because I have like 2 or 3 options to convert to test. Maybe I select the incorrect one. A ver.
I just chose the first one, honestly. I didn't.
Test Unicode or test delimited?
Test delimited, I put, but anyway, in any case,
Vale.
I just copy and paste. But text delimited, it might be the one that you have because it's delimited by comma.
I'm going to paste into the chat the 3 separate columns just to save a bit of time.
I tried to import the
It's
text,
an error.
but it's not possible. Okay, so yeah, the first column.
Oh, I wonder if I can paste all 3 together, actually. That might even be better.
Thank you.
Oh, yeah, there we go. There we go. There's the 3 columns.
Thank you.
Yes, it's true that we cannot share documents, but we can paste things.
It's better if you share one by one, because if no, like the first one.
So if you're able to share your screen, Carmen, maybe we can talk it through with your computer.
No, now I think it's working. A ver.
Okay.
No, I cannot copy, no. I don't know why. A ver, I will share, okay?
I'm trying to copy also.
A ver, I'm trying to copy.
No, it's not
but
possible.
it's not working, it's not copying
it.
So now you've got to, it doesn't let you paste without you actually having to, if you right click.
Okay.
No, right click,
copy
right
here.
click, yes.
Sorry.
Yeah.
Yes.
Oh, that's the but yeah, if you have to
paste.
actually press paste, yeah.
Copy, pasting table. Okay.
It's one of those strange things with this software that doesn't, it doesn't let you do that button for some reason.
Maybe we can do manually. So you do the numbers, you say the numbers, and we do very fast manually, no?
It's not. It's not pasting it.
If you right click on the tab on that, on the actual tab.
Carmen, you right click on the view.
On the mouse.
Yes.
Yeah, I'm here. Okay, and I copy,
Yeah.
and then I came here and I paste.
Right click.
In
Right
table.
click.
Carmen, you right click on the 0. You right click on the 0.
Right click on
yes, you right click on the
paste.
0 inside the cell.
But
and
paste.
But
Yeah.
still it seems not.
It's not pasting.
It means
Oh.
it's
Not
not copy.
pasting. Me, I'm trying also. I think we should
It
do
means it's
manually,
the
no?
copy that is not good.
No, how manually? Let's try something
It might just not
different.
allow to copy it.
It's not a lot of numbers. It's how many 0.5? It's 1, 2, 3, 4, 5.
It's not a great deal numbers, no. So shall I just dictate? So it's 0.
Move
forward.
0.5?
Yeah, and you can. So maybe Carmen, you can watch through Maite's screen for the moment, but it would, you could. I mean, I'm not quite sure what the problem is there, but it's, but yeah, I mean, you can put them in manually. That's certainly one way to do it.
Yeah, but
but it's what a pain.
later I can try to solve it. Don't worry.
Yeah.
We can go ahead.
But I think Andrea and me, we have the same problem, eh? So it's not just Carmen.
I'm not sure what's going on there, but well, normally you can right click and then press paste, having copied it, or you can import it as a text file. So that would be the other thing that could be done.
The problem, when I try to import as a text, also appear an error.
It's because it's everything in one column. For me, it's the same.
Yeah, so it has to be. Well, when you save, we're gonna save this actually in a second, and it will turn into a text file. So maybe we can try and send that as well then through the chat or something like that. But you can see, I'll keep going at the moment, and then maybe we can find a solution through that method actually. So you can see on this data set that.
Oh, Sebastian cannot talk. Wait, let me second. Sebastian has a question. Sorry. It's going to be hard for us to move from this point. Yeah. Allow Mike. Sebastian, we're keeping you quiet there. If you want to talk.
Thank you. I was put out of the webinar actually, and then
Oh,
talk.
we kick you. Sorry.
Thank you.
You're set.
Great.
Yes.
Oh, sorry. You have your question?
No, no,
Oh.
no. It's nothing.
Okay.
Go ahead, please.
Okay, so let's go.
So we've pasted in the data, and immediately it's plotted out on the graph on the right. Now, at this point in time, you might want to already be looking at the data to see if there's any real outliers that need correcting or deleting. As it is, looking at this data set, although I can see a few things that look slightly odd, just a couple of things really. For example, if Mighty, you move your mouse just to the left a tiny bit, and then down, that one looks slightly odd given the direction of the curve as it's going upwards. We've only got we have got, but however, we have got 3 MN readings, and that spacing is 20 meters. So you'll note that we have a 20-meter reading at 0.5, a 20-meter reading at 5.
20 meter, these 3, right? This 3 that is 10, 10, 10, in fact, is 20.
Yep. So in this, so actually it will be easier in the next moment. But you can see that the data's plotted. But the reason you've got these data sets that might be duplicated is because in the same spacing, that is, they're duplicated in the same spacing, is because we have moved the MN probes outwards, but we've redone the reading in order.
Right, I see this. Now
Yeah.
I understand it. So here we have AB, we had 20, 30, and then we passed with 0.5 MN, and now we go back for the AB, 30 and 20 and 30, sorry, with this MN of 5.
Exactly, and the reason being is what we discussed before, that mathematical rule where we can't have the spacing of MN greater than I'm going to forget it off the top of my head, but greater than 30 and less than 3 of the I'm afraid I've forgotten the formula off the top of my head, but we've got to follow that mathematical rule, which means that we need to expand the MN distances to keep the rule as we continue to expand the AB out, and then we repeat the measurements a couple of times for certain AB spacings to get continuity in the data for this analysis. So we've put that down. There's nothing actually there's no negative numbers. There's nothing very clear to correct. So based on that, we press OK at the bottom, where the green.
But I didn't remove any of these ones, huh? Is that okay, right?
Yeah, removing nothing. No, removing nothing. So now we can save this as I think it is a text file that it's saved at, but it's saving it under IP2 Win formatting, and we can call this just
yes.
Yeah. And you can see now that the next thing that's come up is this graph. So if you, oh, that's slightly odd because it's only come up with 2 MNs. Sorry, Mighty, can I just have a look at the text file again?
Sure.
Behind?
The text file, this one. Okay.
Oh, the one,
I have to
below,
close it.
below it.
Uh-oh. Not this, right? This here. This one, it might be this one that was, oh no. This. No, it's here on the right. Not this, no.
Yeah.
The other one has disappeared. I don't know where to find. Let me.
Oh, well,
A new base point. I do it again. See. Or wait.
I think if you do it again, you might have to close the program down and just.
Okay. Well, tell me then what you want me to.
Yeah, maybe shut it down and reopen it again. Unless. Okay,
let me just close it from here because. So, let's just start with this IP something, opening it up. Okay, seems that it still remembers this.
Okay, if you expand those out, those 3 things, that's no. Okay, yeah, click on new.
New. Okay.
And now
let me
you
see if
can
I can open
text. Yeah, exactly.
So this is the one that I had created.
Yeah.
As text file myself.
So you can open that.
Oh, that's the error that they were saying that it happens, I guess.
I'm
the
not
error
sure
might
why.
be because of the order. The order, do you think the order of the order might have a challenge on that? The order of the columns? Let me just copy.
It seems like a bug, actually. Yeah. There are different software that do the same thing, by the way. So it's I've chosen this one because it's really well, I quite like its simplicity and its and the fact it's free. But
you see, because perhaps before I was selecting some, so let me just now put OK, right?
Yeah, you can see that there's 3 MNs on your data. There's a 0.5, 5 spacing, and 10 spacing. So I'm expecting to see 3. So yeah, if you press OK now and
3 curves like that.
Yeah.
In the following one. Oh. So now it's asking for this. I'm going to put new vis, like I will just put like this. Still 2.
That's.
And when you click on MN average 1 or 2, it's changing.
Yeah.
Normal.
Oh, well, here 1, 2, and the average.
That's right. Now what we normally do with this. So I'm going to ignore the fact that I thought we had 3 MNs for the moment because I'm not quite sure what's gone on there. But what we've got here is a graph with the different MN separations marked slightly differently, but you can see the overlap between the spacings between the where the AB's been the same spacing, but we've got a different MN spacing. And if you think about it, as you expand out the MN, you are going to get a different reading from that because you're looking now at the voltage difference between a larger area of ground, even though the A-B spacing is the same. So that's the reason that you get a slight different reading. Normally, I follow the bottom one, the number 2, as it were, because you're getting a larger area to sort of get a larger average, basically. So now with this data set, you can see that we have got, it's not completely smooth. And if you remember previously, the smoother the graph, probably the more for a theoretical interpretation, we need a smooth curve. So we might look at this data set and think, should we slightly correct some of this? And you can, if you want to, select one of those dots there and drag it to create a slightly better curve. Yeah. And you will see that by doing that, you'll also be changing the rho value, the apparent resistivity value in the table. So you can also go the other way around. You could say I made a mistake with writing that out, that particular value. Let me correct it in the table now, whatever the rho value is, and it will change on the graph. So once we're happy, and so I think what we would like to do actually, if you do just for the practice, we drag that down a tiny bit to get a smooth line going up there. Yeah. And let's see that.
No, I just click outside and it went down.
And you can see that's also corrected a little bit, the blue line above the average 2. And then looking at there is then see that if you click on that, exactly, and drag that a tiny bit up.
It's better. A bit more, perhaps.
Yeah, and I think potentially we'll just leave it at that. But we've done a little bit of correction to try and make a slightly better curve, if you can see what I mean, and remove get a bit more smoothness into it. And now we can press OK on the green.
Here.
Yeah. And now what we've got in this section. Yes.
Boris has a question. Boris has a question.
Yes. Just to make sure I'm really understanding this, to make the link between this and what is happening on the field.
Yeah.
Now, talking about adjustment of this graph at this level, it's not like a kind of cheating. Is it reflecting the real data that we collect on the field? If we adjust it at this level, I don't know. I'm just trying to see
it's a good question.
Yeah.
No, it's a good question, and something definitely to be hesitant about. The key point I'm trying to illustrate here is that there might be rogue numbers. There might be, so with certain readings, there might not be the best contact on the ground with where the electrodes are, which might result in a rogue reading. And we don't want that to skew the results. We want to because we're looking at, going back to the averages again, because we're looking at large areas within the, as in when we're taking these measurements, it's taking the measurement of a larger area. We have to try and we know that theoretically that results in smooth data sets, because as you expand things out, you're going to have a gradual impact of any further layer on the resistivity reading that you get. It's best for us to try and make the data look try and correct it to what we think is the most realistic as possible. So I wouldn't want to change I'd only want to be changing small points or outliers here or there to smooth out the curve. That's all I'd want to be doing, nothing else. Does that make sense? So we're not trying to change the data collected, but we're just trying to remove the outliers that are obviously not recording the correct information. Maite, could you go back to the graph?
I think Aurora has a question, but we can still go.
Oh yes, yeah. Sorry, go for it, Aurora.
Yes. Sorry, I didn't get why the MN is changing. So in the initial we have this 0.5 and now we have 2.223. I didn't understand why. And the second question is why the two graphs. Sorry, I didn't understand why there are two graphs, because I understand. Okay. Yeah. These are different.
So the MN number that's 1122, that's just the number. I mean, that's a programming thing, just stating that the first distance of MN is the 0.5s or MN distances are all being grouped into group 1. Then the 5s have been grouped into group 2, etc. Yeah.
Okay.
I don't know which one has been. It seems like around here is where they have been done the merging. Those two, I think, has been considered as one thing, but I don't know.
But
because it's only 2 groups here, 1 and 2, not 3 groups, right? That's what you wanted to eventually have, right?
I don't understand that myself actually with this data set. It's not normally, but
you think it doesn't understand the dot, like 0 point something or 0 comma something, and it has only thought. I don't know. You see sometimes because of your system, British and others, that some has commas and has points. Anyway, possibility, but
I'm not sure. But it's not too important because it's at the very end of the reading, and you can see. I think it might be. You can see the additional dots there at the end of the reading where it's incorporated them two together. So it's not. I'm aware of what it's happened, but it's not going to. I don't think it's going to affect our interpretation at all, actually. So I think we can ignore it for the moment as a blip. But what would have? But what we have got here is clearly from this data set. What kind of graph is this? How many layers do you think would be associated with this data set?
Three.
Yeah, exactly. We got a starting point with a row of around 600 from what I can see from my from
600 something.
Yeah, and then it's dropping significantly down to potentially somewhere near 100 somewhere. It's before it gets to 100, it's being rebounded back up again, and is going up at a fairly 45-degree type angle, relatively similar to that. So we are reaching a significantly higher resistivity layer with a less resistivity layer in the middle. So very similar to what we might expect within a weathered basement type of aquifer system.
So that will be the weathered, then you get the weathered with water, and that will be the unweathered. So exactly. The third one.
Yeah. And I mean, and that pattern could be repeated in other types of geological environment too. But we've got an unsaturated zone with a saturated zone followed by something far more resistive below it.
Or something.
Yeah. So what you can do next is that if you, at the moment, we've in that box in the corner to your right, you can see that there's.
Oh, to the right, yeah.
Yeah, that's it. Yeah, you can see that at the moment there's just two layers being derived there, and there's an error with this graph of 63% at the top because it's just trying to match this curve with a two-layered system. Yeah. So what we want to do is
that's the error that it's assuming that we are having with this interpretation.
Exactly. So what we want to do now is we want to right-click on the blue line somewhere. And
I can move it.
You can move it, but if you right-click on it.
Oh, right-click on it.
And then say split.
Split.
Then we've created
we created another layer. Yeah.
A third layer. So now, Maite, if you drag that third bit up, as in the third
if I drag this line.
Yeah, on the right-hand side of that your split. If you drag that up.
Look at it, even like this. Yes, that's what I'm. Yeah.
That's right. And then try and drag the other lines around and see if you can start to match the curve with
sort of like this.
Your interpretation, exactly, that's it.
Then here I might be able to put it down. Yeah. Oh, those were those lines I was asking you about that. I don't know why the people. Okay.
That's looking pretty good. Yeah. So what you've done is curve matched there with the data set with a curve, and that curve values are on the right hand side. So what we've come up with through matching the data with the curve is that we have a primary first layer of 632 ohms per meter, which is about 2 meters in thickness, or 1.6 meters in thickness, followed by a much more 70-ish ohms per meter with a total depth of a thickness of just 3.5 meters with a total depth then of 5 meters, followed by
okay, this is total depth, this is the okay, so
yeah, and then followed by a much more resistive layer. So what is this telling us? If I mean, we obviously have no context
here the
of
error is very low.
The error is great, actually. Yeah, the error is good. It's below 10%. I mean, what's this telling us? It's telling us that we've got potentially a fairly thin saturated thickness of up to 3.5 meters with a shallow groundwater system. And then, I mean, that's one interpretation. But of course, as we talked about previously, if we have more understanding of the geological context, we might look to reinterpret this in some way. Now, what another cheat? So has everyone had a go at that? Has everyone been able to sort of fiddle around with the data to some degree, and the people come up with the same results?
I got lost a little bit when we had to create the third layer in the error table. I was having the first question why because my error value in the beginning was very much higher than hers, but I want to assume it's because of the matching of the corrections that we did in the previous, so that passes. But I got lost a little bit how she had to create, because I have layer 1, layer 2, but layer 3, how that was created.
Yeah.
I click around here, right, or something?
That's right. You right-click.
I right-click. Look at I'm here. I right-click on the top of this blue line with my right, and then I put a split.
Split. Shukran.
I have one. If I put a split again, it will still divide another time?
It will, yeah. But you can then also join. You can see that join, so you can remove that as well, that split.
I have this result, but I don't know if I missed something, but the red line for me is not with the black one. So
yeah, because then you have to move it. So then you have to play. I was moving this one. So you just stop and click in the left finger. You move it up and down. You try to adjust it.
The red also,
and then you click on the left one and then you adjust as well.
Yeah.
So you make it, I guess now I did it worse because of this error here. So that's better.
But for me, if I move the red one, I move the blue one. It's like to move. Okay. Yeah.
Both of them move together. Yeah. I think the one that does not move is the black in the background. That's the one you're trying to mimic.
Okay. So now you try to put the red one in the black one, and you have the okay. Yes. Now it's similar.
One interesting fact, we were talking about the how you can have a thin layer of higher resistivity and thicker layer of slightly, sorry, a thin layer of lower resistivity or a thicker layer of slightly higher resistivity. So if we think to ourselves, right, actually, the resistivity of this material is actually going to be the resistance of this material is going to be less than or greater than, we can experiment by changing also the p value, the rho value.
This one.
Yeah. So we could say we want a rho value of 35, for example. If you put
I can
30,
change here.
yeah,
Oh, yeah.
and then enter, and then we just want to, and then try and make that
Fit it.
fit it through. Oh, that's all. So if you're going up, you're going. If you move it up, you're moving the resistance. But if you move it sideways,
Like this.
Yeah. That's it.
Okay. Oh, I understand now. Now I'm changing the thickness to represent this 35, but the same.
Yeah. So now we've got.
Now I make it 1.5 rather than 3.
Exactly. So you can see the challenge here a little bit, because you can. And does that answer that question that came up earlier on regarding how you can play around with this to try see how that factor impacts? Oliver, you've got your hand up.
Yes, just to find out now, when working with all of these trends to do this curve matching, what is the error margin we should strive at having? Because we cannot have, is there like a range we should like say, okay, this range is acceptable if I do my curve matching and I'm in 25, 35 down from 100, is that acceptable or not?
I mean, I'd be aiming for less than 5%, I think, but I don't know if there's a general rule or not. There is a bit of a. I've been talking about this curve matching, but there is a cheat to all of this in the software, of course. We can go see that lightning bolt in the tab.
That lightning.
If you go to your left and then up.
My left, up.
Yes.
The lightning.
Below
the lightning.
Below
this
section.
One.
If you click on that.
Just under section.
Yes.
It matches it for you to some degree. Now, if you were to, you can either right click on the blue tab.
On the blue tab.
On the blue, sorry, the blue line. My apologies, my blue line. Yeah, and then click join this time. So we're back to a two-layer system. Now click on the lightning bolt again.
Yes. And now the lightning.
Yeah.
Sorry.
Yeah.
Now.
So now that's
so this is what it's doing.
Its attempt at trying to make the best fit out of a two-line model. Now, there's one other cheat, and that is if you click on the green button next to the lightning bolt.
This one. Automatic minimization with the number of layer selection.
Yeah.
But then now we only have 2 layers, right? I should go back again to say, no, in fact, it's 3 layers. You try to create it fit with 3 layers.
No, try clicking on that green button a second.
Okay. Wow.
So
yes, he has created the 3 layers.
Now it's tried to get as much of a match as possible based on, this time it's a 4-layered system. It's decided that it's a 4-layered system. Now, this is where you have to watch out with contractors, really, because what they will do is they will get the data and then click on that green button straight away, and then they will outline the results as in the table like this. But the question, I guess, would be, is that a true reflection of the geology underlying the site or not? And if you see something coming out with about 10 layers, of interpretation, then we're really looking at very bad, first of all, probably a bad data set, because the software is trying to do its best with probably a bad data set. And in terms of the resistivity values are captured during the vertical electrical sounding and not smooth, and not, there was problems with connections or whatever it might be. And then it's poor interpretation as well, potentially. So do we believe in this? I mean, we don't have any background on this particular data set whatsoever, so it's very difficult to comment, but it's suggesting with that ideal curve match, and you can see the error there is 3%, 3.8%. Yeah. And we've got 4 layers with a high resistant initial layer at about 700 ohms per meter, then a low resistivity layer of 50 ohms, 2 meters, and then 20 meters of slightly, well, medium resistivity before going into a more resistant rock again. I mean, for me, that doesn't make, for me, I would, because I would always try and simplify things as much as possible. So I would probably revert back to the 3-layer model, and then utilizing that lightning bolt, go, yeah, that's probably going to be, for me, the best fit for this data set. Yes, Aurora.
So this 4-layer setup is the recommendation of the program, more or less, no? It's like the conclusion of the program, because
Exactly.
it's quite different. If you are going to do a borehole, it's quite different, no, regarding the information with 3 layers, because in this case you have less space until the.
Yep. So the program's recommending, but that's based purely on mathematics rather than on anything else. So, but and the reason the program's got the lightning bolt button as well as the green button is it's saying, well, yeah, you have any options to change the number of layers based on your understanding. And the reason it's got the manual as well is because it might be that even we go to the manual rather than, if we had more information about the thickness of a particular layer, for example, based on a geological log, we could put that information into the spread, the table at the right, to even correct the data more.
Oh, yeah.
Okay. Okay, makes sense. And another question, I have a slightly different values, but I think it's because finally I insert the values manually. I didn't do, I think you were doing the kind of
I was adjusting.
Adjusting. Okay.
Yeah.
So yeah, this is that I missed. Okay.
Exactly. Yeah, and I don't know what the values difference would be, but it's probably very insignificant because we didn't do very much alteration really. But
this automatic green arrow, sorry, it will always try to add more layers, because the more layers it adds, it minimizes the error, right? It just tries to fit, I don't know.
It doesn't always. No, I think it does try. It doesn't. I don't know exactly what it's doing to get to the result. But all I know is, but I do know that it's a useful tool to try and see how the model is suggesting things would fit. But then you need to go backwards to your own geological understanding to see if it actually makes sense. Okay. And simplifying things to a minimum number of layers probably is better than overcomplicating things, given the uncertainties already around the data sets.
So one other question, like now these values of resistivity, would it make sense as well to say this is a weather granite and this is the granite with sand with full of water? Are these values of what you would expect to see for those materials as well?
Well, okay, no. So would you, looking at this data set and this particular interpretation, if we cut it back down to 3 layers a second.
Okay, let me see how we do that. So for that, we'll just join, right?
Exactly, yeah.
And then we'll just press this one.
Perfect.
Okay. Yeah.
So using a 3-layer model, we are looking at those results on the table on the right. Is this going to be a good aquifer system for a borehole, in your opinion?
Well, if you ask me, I say, I mean, I will be looking at trying to have, I mean, more depth of the layer that hold the water. Knowing that the one below, I mean, I don't have more water unless I really know that it's linked to something that is going to bring me water all the time. I would feel that we might just use that water quite quickly. But I don't know.
No, absolutely, and that would be exactly how I would feel about that as well. It does not look like a very
Productive.
interesting target on the face of it. It looks like there's very limited saturated thickness, if that is saturated thickness, before we're getting into quite resistive materials.
But
so
it's very
I mean,
shallow as well, right? I mean, everything is very shallow.
Yeah.
So
yeah.
then for
So
a hand pump, perhaps.
This is quite classical profile for, you know, being on a slightly elevated area where there's not much weathered material and very little saturated thickness. So it's it doesn't look very attractive looking on, but we don't have any context. It's just a raw data set, and obviously we'd have a lot more context when we'll have in the next example. But I think we're almost ready to get on to the main case study if everyone's good with utilization of this software now. Is that I know it's been a rushed introduction, but that it's quite simple software, and that really is the basis of it. Any questions on that?
Oh, Theodore cannot talk. Well, let me see.
Andre.
Yeah, I was going to ask about the adjustment that Maite did manually to reduce like the percentage of error, you know. Because when we try to insert the data already, the software give us automatically the percentage maybe of error that we may be having. No, adjusting it manually may have any impact in the following step, like if really.
Andre, we are losing you. I think your microphone may be.
Your mic.
Yeah.
Are you getting me now?
Now, yes. I can repeat the last part.
I was saying that if we enter the data, let's say manually, and after we have entered, we have inserted the data, we have like a percentage of error, like it was 30, 34, something like that. And now adjusting this error manually so we can have the better queue, okay, will have an impact in the following step, or it doesn't have any effect.
Yes, it will have some effect by changing the data set in the previous step. However, by smoothing the data set in some degree, if there's obvious error in any of the other data points within the previous graph, then it's better to correct those so that we then can interpret the data set more realistically, rather than letting that data that's obviously wrong skew results, if that makes sense. So, but if you don't correct that outlier, then there will be increased error in the result. Yeah, in terms of that error number. But we go through a cleaning process of data, really, and there might be, I mean, that was quite a clean data set, to be fair. Some data can be really quite a lot, you know, much less smooth than that, and then trying to make sense of that data, you know, you do need to do some correction just to try and make some sense of it, and of course, knowing full well that it's been fairly poor quality data collected, so therefore having less certainty on the the result.
Okay, thank you.
So I'm going to go back to sharing my screen just to introduce a kind of, well, introduce this case study that I'd like us to all work through, which I hope will summarize what we've been learning about over the past 3 hours. And can you see my screen again?
Yes.
Yes.
Yeah.
Yes.
I'm using an old case study because we've got the GIS maps, etc., already sorted out. But the geophysical data is a really good data set anyway for the for this work. So it's based on a borehole that was sited in Central African Republic. Maite, you might even remember this from Silso, but it's based on a hospital called the Powell Hospital, where Médecins Sans Frontières OCF, I think, were looking to get a 3 meter cubed per hour supply for the hospital, but the borehole, which was coming originally from this well here, was that the borehole that was supplying the hospital from this well here was only providing 0.7 meters cubed of water per hour. So MSF wanted to drill a new borehole to get to meet the demand 3 meters cubed per hour. A desk study was carried out to support the initial conceptual understanding of the aquifer system. And if you click on this link, you'll be able to go to where the data sets are, etc., for this desk study. But to run through it quickly in summary, this was the geological map for the area. You can see that it's the pink is granite, is a crystalline granite, and these lines here are faults that were running through had been geologically mapped to run through the area. Going northwest, striking northwest, southeast, basically. So we've seen this already, this diagram, but this is the kind of crystalline bedrock, therefore, we're expecting as a conceptual understanding and model. To look at the hydrogeological properties of a weathered basement in a little bit more depth. We often get more clay-based deposits further up in the weathered zone, which have large storage capacity, but very poor transmissive capacity. But then as we get towards the bedrock, there's more quartz sands associated with granites, and then which are much more transmissive. And so this is actually a very good aquifer system as a result, because you have a transmissive layer where you can get the water, but a large storage volume of water potentially within the clays that can then feed, that can gravity feed to the more transmissive area that you're pumping from. And then there's possible fractures in the bedrock itself, which can also significantly increase the yield of the well. So during the desk study, there's the hospital footprint, and this was the area in yellow that was marked as being possible for land access to drill a borehole. So the overall perimeter that could be explored was limited to the yellow box. And looking at borehole records that have been procured, but not procured, have been obtained from the Water Authority, ANIA, there were several records that were quite close by, and they were suggesting a static water level of around between 4 and 8 meters, with a weathered zone of around 30 meters. So this was useful for then deciding on determining the geophysical spacing that might be required to carry out the initial constant separation traverses, because of course if the weathering depth is around 30 meters, and we know that we wanted to get about 0.2, we would have to separate out the spacing of the electrodes to around 120, 150 meters to reach that 0. To reach 30 meters at that 0, you know, as our principal exploration depth. Topographically, we can see the hospitals right in the center here, and we know that there's regional structure going north, west, south, southeast. So perhaps something coming down like this and coming down like this. By the way, regional structure, any kind of regional structure is always reflected in local structure as well. You can see the shape and size of a massive fault by looking at small fractures at the same time. But there's also, looking at the topography locally, perhaps other structure that the geological map hadn't picked out than those regional structures that might be going this direction as well, sort of more of a north, west, southeast direction. And this one here as well, going a north, east, yeah, southwest direction. So 1D geophysical survey work was undertaken with a Schlumberger array, and the profiles were carried out basically all around the perimeter of the hospital. And I'd like you to open up from the information that was shared to you just now by Maite, the PowerPoint that says, I think it's exercise 1 or exercise deciding on locations for vertical electrical soundings. Have you got that in front of you?
Yeah, you have the one that it was called Paua Hospital VES uncorrected, or without the uncorrected.
Oh,
that's what you're saying?
No, that's not what I'm saying. I'm gonna.
Oh,
it's okay.
No, there's a PowerPoint file. There is a PowerPoint file, Maite. It's called task
the PowerPoint.
PowerPoint.
Yes, that one. Yes, I was just thinking.
Which
electric location. A PowerPoint.
Which PowerPoint do you have?
Task select drill location from Power VES data.
Yeah. I thought there was an error, and I think I'm going to send you something else. There's no. If that's okay. Sorry.
She's okay. This one has 3 slides. One that has the scan of 3.
There's
electric
one
vertical sound. Yeah.
There's one other called task select VES locations from PAL CST. Have you got that or no?
Repeat the name of the file. Task
select task select VES locations from PAL CST data.
No, the best no. It says task select drill location from Power VES data.
Okay, 1 second. I'm just gonna send this to you, and then you.
It's okay. I can just put it inside. Drag it inside. I will be fast.
Yeah.
As soon as it gets here.
Okay. Great, that should be coming towards you, and I'll carry on in the meantime.
You carry on, Jesse. I'm waiting for this and then
Yeah. So going to these, so on these, so these are the constant separation traverses that were carried out. And now I'm just going to show you each of those constant separation traverses, the data sets themselves. So you can see at the bottom of the line, there is the distance again. So that's the distance between each measurement taken. And you can see we were doing them at 5-meter intervals, the distance at 5-meter intervals. And then this is the apparent resistivity that was being collected along the profile. So in this particular case, the profile went from east to west, and this is the results of the profile that was collected. Does that make sense? And that was going along this line here.
Mm-hmm.
This is number 2. So this is going from north to south, actually. And so this is north, this is south, and this is the profile that was collected for that one. CST3 is this one up here, and you can see the profile line that was collected from that one. CST4, oh, my apologies, CST4 is this one going along here. Ignore that, because I initially thought I'd just give share 3, but I in the end decided to share the full 5. And this is CST5, which is measured, which is enabled here CST2, but it's not. It's CST5, and this is the run. This is going along this direction here. So if I go to the original map, you'll see the CST5 running along there. I hope that error is not on your the case study that you will have in front of you in a second. But what I would like you all to do is to look at the CST, these files, and decide on which ones, on where you would carry out vertical electrical soundings based on the data, on the constant separation traverse data collected as a task 1. Okay?
Okay. I think everybody might be able to access to that document. Is here now in the link is in the chat. Just tell me if it's okay
Yes,
for you when
Alice,
you
I
open
have.
it.
Yes. Okay.
Please feel free to open it up and mark on it with arrows or whatever it might be where you think you would put vertical electrical soundings, and then perhaps have just 5 minutes, and then we'll see if we're all in agreement on that.
I have a question. Was there any reason why the distances between the things are different? Because I saw 5 and then 10 meter later one, and the other one I think less than that. Was there any reason?
Speed of surveying was one reason, and there's also this idea of, so in addition to the geology, we also want to have a practicality of where to drill. So there were some areas that were slightly going to be more difficult and challenging to drill, but that wouldn't put one off. But I think it was mostly down to speed that in the end it was decided that 10-meter spacings would be sufficient rather than 5-meter spacings.
Jaren, I have a question as well. The numbering, I'm not sure I'm with it. I know I'm not with it. Sorry, I'm just like the numbering of the labeling of the transects that you are proposing, it changes, right? Or is there in a slide, should it be all the time the same?
No, It should be no. That's my error.
Okay.
And I apologize for that. I
Okay.
basically was going to initially, when I was preparing this example, just going to share 3 of the transects.
Okay.
So I changed the numbers because
The
it wouldn't.
numbers.
But actually, this is the real numbers. So CST1, CST2, CST3, CST4, CST5, done in order of done an order of when they were carried out.
Okay, because in
So,
slide
yeah.
5 and 6, I think there's this. So then we should look at the other slides, the other one.
Yeah, please
Okay,
ignore
great.
that picture on the right. I should have corrected that, but I didn't.
It's okay, just because I was. Awesome, that's good.
Yeah. Oh, sorry, I wasn't sharing my screen then. I'll put it up. This is the correct one. This is the actual order.
Yeah.
Let me know when you're all happy, and then, or if anyone wants to put forward any ideas initially, please just share your screen and put forward the idea.
Is the one.
We have to choose one or different points in the different graphics.
Yeah, no, well, I mean, it would be as many as you think would be of interest, really, as a target. So obviously, it would probably be better to have more than one, because otherwise you're restricting your decision on drilling to that one location straight away. So, but if you had 10, it might start to take a lot of time to carry out the survey work, and it might, not having more necessarily isn't needed, depending on the data sets. But so just be finding the most, what you think are the most suitable targets.
Could you repeat where was the location of the borehole? Is that little red thing inside in the middle of the health facility, or in which corner was the current borehole?
The current borehole is at the bottom. It's it's right at the southern end of the hospital, on the boundary, basically.
So in those transects, it would be around where
let me show you.
CT5, CT4, CST.
The current borehole is, I think, this construction here, if you can see my screen.
Yeah.
I'm not able to put the arrows on the PowerPoint I have, but I can give it a go.
Excellent. Go for it.
Let me break the ice.
Yeah.
Voilà. Tamam. For the first for the CST1, well, what I was looking at first the apparent resistivity values for all of them, and try to identify the lowest ones, like the troughs in all of the graphs that are presented. So for CST1, I see we have like the lowest approximately something, we are somewhere between 120, 150, somewhere in that range. So there's two probable areas at about 50 meters and at about 20 meters on CST1, which I could consider investigating. That's for
Excellent.
CST1.
Yeah.
For CST2, I decided to skip this one because the resistivity values, the lowest here is quite high. It's over 250, or it's over 200. So I decided for now to skip this one. For CST3, we have very, very, very little resistivity values. And I'm like, is this not a clayey surface? I think it's more of clay than something that could be of interest to also CST3 I passed. Then CST4, this I'm having kind of a doubt, but if I'm going for this one, I'll go for VS at about 120 meter on the CST4. Again, with respect to the value of resistivity that is recorded. If I read well, this is between 101 and 200, if I'm reading very well. Then on the 5, it's approximately 120 meters. That's an area that looks of interest to me. And voila, so in principle, 2 on CST1, 1 on CST4, 1 on CST5.
Thank you very much. Has anyone got any other thoughts on that, or any other ideas or thoughts, or are we all in agreement? What Oliver suggested.
I put in the chat, I was including the 3 because this very low resistivity, but now I'm not sure. But because in the 3 it's clear that the resistivity is much less than in the other profiles.
Yeah. And if you look at the location of where number 3 was carried out as well, along the edge of the road, it is very interesting how that it doesn't look representative of the other resistivities at all, does it? It is an interesting anomaly. Well,
for me, I don't know if it makes sense or not, but like I was looking as well where those dips were within that transect, thinking that they are, starting from the left to the right. And then thinking about what you said about the features that go northwest, northwest, and south, and thinking that those dips somehow coincide a little bit if you put that line, in that section and the other one. But then, yet the borehole that they have now seems to be quite well positioned, right? According to these features. So then I got a bit puzzled there of, I don't know, that makes any sense or not. Anyway, but yes, align with Olivia. 1/5.
Excellent. Well, I'm going to share back my screen. So I think, I mean, it's almost like Olivier was doing the geophysics himself at the site, because the sites that were chosen in the end for the vertical electrical soundings were exactly what he was suggesting for constant separation traverse 1, here and here. And then in the end, it was decided just simply to go and do the VES 3 on that low profile, and on the constant separation traverse, that should be 5, not 2, down here. I mean, the reason, I suppose, I mean, that the idea to not go further to this sort of point is that we don't really have much of a picture of what's going on beyond that. So it wasn't a very good signal at the edge of the profile because the data hadn't been collected to carry that on. Although it might have been interesting to have continued the line in hindsight. I think, but yeah, can everyone see why these points were chosen? It's to do with the shape, the fact that they are the lower points on lines, but it's also to do with the values, resistivity values. But excellent. So going on from there, the VES data was then collected through carrying out vertical electrical soundings at those points, which I'm hoping now you will be able to access through the next document, PowerPoint, and also the Excel file that was shared. Can you open those up?
You want people to open the other presentation that you put there?
Yeah.
Wait, because then, as not to confuse, I had deleted it. It's not a clever thing.
Are you putting in the chat?
I'm saving it back again in the main link, and then then I can share it in the, yes. It's the one that says select grid location for Papua. Copy, share.
And it's just summarizing the data, that particular PowerPoint, but then there's the Excel spreadsheet as well that has got I think it's called Power Hospital VES Uncorrected Excel spreadsheet. So, and within that Excel spreadsheet, you'll find 3 tabs: VES 1, VES 2, VES 3. And the challenge that I would like to set to you now is to use the IP2Win software, IP2Win software, to analyze those 3 VES data sets and to select what you think will be the best one for drilling based on those 3 VES. Is that clear for everybody? Yeah, great. So
Yeah.
it might take a few minutes to go through the 3 VES, and what I suggest is once you've done one, you screenshot the output, the table and the graph output, so that you then have it to compare against the other 2 as you do the other 2.
Oh, you want that we split it, so we go faster.
Up to you. It's I'm not sure how much more time you have. I think it would be nice for people to try to do the 3, because it's a nice exercise to start to use the software.
But it's an image, no? So we need to insert manually. Okay.
Is it not working? Is it not working, the Excel spreadsheet for you, either the other one?
No, it's working. It's working. It's different.
Oh, okay, good. That's a relief, because yeah, that would take some time.
Mm. Mm. Do you want we share it like this? I put, or we don't share it?
Yeah, no, absolutely. Please feel free to share. Yeah, it's do you have you come to any conclusions yet, or is it how far have you? Is it number one? Okay. No, sure. It's it will take a bit of time. I like the red pen.
Just to try to see how
Yeah.
to pass this.
Can we have more than one at the same time in the program? More than one curve?
I think it's possible to open up two. I always shut it down and reopen it because it gets too many tabs. But I think you can do it with more than one in the program. But I must admit, I don't. I'm my tactic is to shut down and start again.
Because I cannot do it for the moment, but I continue looking.
Is everyone able to utilize the program now? Is there anyone having any problems still with the program itself, or
Working for me.
Yeah, but I inserted the numbers, but the graphs are not appearing.
You have to press OK. I think, are you pressing the OK?
Yes, but it's asking me to save.
Yeah, I'm
Yep.
saving it, whatever. You save and then you go and it appears.
You do have to save it, yeah.
Sorry, what was the, because I think finally you did, I did the question before, but I'm not sure I received the answer. What is the blue curve? Why we have the black one and the blue one?
The blue squares, as it were, are for you to be able to, you can just drag those around. So they're for you to be able to manually manipulate. They also show where try to be a bit more clearer about what the depth is and what the resistivity is, you know, in terms of where you're dragging them to. But they're the manual way of moving around the curve matching.
But I mean this thing that you can change 1, 2, 3 average.
Oh, yeah.
In the previous step, yeah.
Yeah. So those are the M and N different distances that are being utilized to collect the overall vertical electrical sounding to keep the mathematical formula stable as you're extending out the your outer electrodes. So in general, what I would normally select the final spaced electrode as a sort of rule of thumb, but the only because with the thought process that you're covering a little bit more ground with that that final spacing between M and N. But if there was a problem with, maybe because you moved the outer M and N electrodes out to a place that had a poorer conductivity, you know, some tarmac or whatever it might, some issue, then you might use one of the more inner electrodes to do your curves instead. But as a rule of thumb, I'd go for the outer one.
Okay, so in this case, I can choose average 1, 2, or 3. You will choose 3.
Yeah, that would be, I suppose, the first choice.
Okay.
So the location of the steps finally was, the first and the second one was in this profile CST1. It was that order. And then the number 3 is in the CST5. Am I right?
Yeah, so vertical electrical sounding 3 was in CST5, yeah. And then the 1 and 2 were in 1. Yeah.
Okay. Me, I changed one value. I changed one value that it was 23, but it was fully off. I don't know if I did some mistake. It was very outlier. Could that be for the CST?
That's fine. I mean, it's if that's what you saw, then yeah. I mean, you'd have to, if you want to share your screen and show us, that's great as well.
Mike, did you manage to have more than one curve at the same time?
No, but you see, I'm not sure where I close it or I delete it on top because I have a hard time to see where the screens go and how to find them again. That's why I was just copying and the screenshots. So I save them as well, just if I had to open them in window. You have the tab window, I think. You might be able to retrieve them there. The window. Okay, let me share. What happened before, what I was saying now is that when I put it inside, so this is for the third, this value for me, I think, let me see in the Excel file. You see, this value is 23.
Yeah.
And if I put here 23 to me, I don't know, you see, it comes here and looking at the data, I thought like, well, this is 293, 274, 230 something.
Great.
So I
No.
directly changed it. So I thought that somebody has forgotten one
That's
digit.
excellent. I completely agree with you. That looks miles below the line. So absolutely needs to be corrected. Yeah.
Okay. So. Mia, you didn't know which one to choose between 2 and 3. I mean, symptom. I mean, it's very similar.
Is that what you're getting? Is this?
I mean, 27, 33. I mean, 2 would be a bit thicker for me, the area with water. But you see, just 5 meters, which, well, is I mean, it's still 5 meters.
Yeah.
But I don't know if that would be sufficient. You see, in this case, it would be very nice to know more because this 33, you see, the number 2 for me, like the top layer is 1.9 meters only, which the other one is almost 4 meters. So being so shallow, the top layer, it feels also very shallow. So yeah, I would be between the two of them, but that's.
I'm looking for where have you labeled that number 2 in your is that there and so you've
The
got
ones, yeah.
Yeah. And number 3.
And number 3, you see the top layer is 3.6 meters. The second one is 27 meters, according to the program. So yeah. The graph looks better than number 2, that's for sure.
It looks like there's something going on in your graph.
I know,
in number
that peak
3.
there.
Yeah, so that looks also like an error that might need to be corrected.
Let me check how see.
I can see can't see who Sebastian, you've posted number 3 with some corrections in there to remove the outliers, which is good.
Yes, I put average.
You put average. And what about the
yes.
outliers? Were you able to correct those outliers that you saw on 3?
Out what? Sorry.
There was Maite's discovered a couple of readings that seem quite a long way off a smooth curve. Were you able to correct those yourself as well?
No, I didn't touch. I just push average and.
I see. Okay. Interesting. Yeah. And you've gone for a 4-layer model too, by the looks of things.
Yeah.
Andre, what's happened with your first measurements? I'm seeing that you've got a 2-layer model, and therefore there's quite a high error associated with it. Can you add an extra layer to that maybe to try and improve the curve matching?
I'm trying. I don't know, because the software here, even the presentation seems to be a bit different, because yours started by 0, 1, 2, 3, but me here the 0 doesn't appear. This rate start by 1.
To try and add another layer, you can either right click on the blue line, the blue straight line, and then say split, or you can go into the actual tools. Is it tools? Yeah. No, sorry. Model, and then you will see a split or join sign in the tab model as well. So they both do the same thing, and that would add an extra layer to be able to help with the curve matching.
I'm doing with the automatic simulation of the program. I don't know if it's not the purpose, but I'm doing with this green arrow.
Well, I mean, I'm looking at one of yours and it looks good. I mean, it's selected 3. The error is quite small. It's selected 3 layers, which is probably what we are expecting given the geology. So I think it's reasonable to utilize that.
Yeah, I'm using this green arrow.
Yeah, you're taking the short route, but it's working.
Okay.
So
yeah, nice. No, yeah, it makes sense. A part of this, I test with this, and it makes sense because this is similar to the exercise that we were doing.
Yeah. No.
And now the third one.
Has anyone else struggled with number 3 at all? Not struggled, maybe is the wrong word. Has anyone encountered problems with number 3?
Yes. Number 3 does not seem to be very good for me.
Yeah.
Number 3, I've done number 3. I first of all also try to correct that mysterious value, and the curve matching as well is not good. I have my 3 layers. The one with I cannot share my screen. I'm sorry, because I'm using a different computer. But the one with where I have resistivity of 17, the lowest is on the 3rd layer. The first 2 layers cumulatively being about 1.6 meters. The 3rd layer with about 4.5 meters.
Yeah.
So yeah, when I go through all the 3 of them, if I go through all 1, 2, and 3, my choice will be 1. For 1 second, let me find 1. For 1, I'm trying to find what I got for 1. Oops, where is it? For 1, I have the second layer, the thickness of the second layer with the apparent resistivity of about 32. I have a thickness of about 14 meters. So that's my thickest, more or less saturated depth. Saturated depth, yes. And given that, if I remember well, you mentioned from the existing boreholes, the static water level is somewhere between 4 and 8. So it means this thickness could be an interesting area for where we could have water. But for 2, I'm having a cumulative thickness. 2 as well could probably work, because the first 2 layers of 2, I have cumulatively 1.2, and then I have another saturated thickness of 7 meters. But the resistivity here is a little bit higher than on a VES1. The resistivity here is 127. For VES1 is 30. I said 32, no? I think it's 32. So my choice will be VES1. VES2 will be the second. VES3 I will not even consider drilling here.
And you're using a 3-layer model, is that correct? Or are you going
3
4
layers?
layers?
Yes, all 3 of them are 3 layers.
Okay.
Yes.
It's a pity. It's a pity. I can't see that because it's
Let me try to see if I can send from my phone.
Yeah.
Yeah, because it's different, very different from mine. My results are very different.
You got the 23, Olivier? Did you put 230 or 23?
So it looks like if it was 23, it looks very out of the rest of the curve. So it's so that is a big warning, I guess, that's probably incorrect as a number, because when you look at the rest of it's almost off the screen, that point when you first look at it on the graph. You could then actually check on the PowerPoint where the real the initial data that was collected on by pen, see if there's a data error in typing it up into the Excel spreadsheet. That could also help to get that number sorted out. But yeah, the data's not quite clean for number 3.
Yeah, it's 233, no?
Aha, that sounds more reasonable. Yeah.
I have written 230 as my text, but yeah, it's similar to 230.
Well, that's a great guess then. So
Yes.
that's perfect, because it shows yeah, you guessed very, very accurately. If you've been able to send that at all, it's gone, isn't he, actually?
It's gone.
Yeah.
Olivia.
What?
Yeah.
Olivia came out.
Or maybe he won't connect from the phone.
Yeah.
Computer. There's always challenges with internet. Andrea, I think now you have to try to match them, one on top of the other or something. To create another layer, perhaps.
What is the difference in the program, Gerard? What is the difference between the inversion and the automatic minimization? Automatic minimization.
Automatic minimization.
The blue
Oh.
arrow.
Oh yeah,
or
yeah.
Or the stop.
Yeah.
Right.
So I don't know how the mathematics works exactly, but the green arrow doesn't just look at the layer threshold that you set it. It looks at multiple layers, it goes through multiple different options and layers in order to get to the best match, rather than being restrained by the layers you've set it. That's the difference. So it doesn't. It's not so constrained as a way of inverting the data to get to the best fit line.
Okay, so the yellow one will play with the number of layers that you have defined.
Exactly. But the green one will go through any number of numbers to get to a good iteration.
Yeah. Okay. Olivier is back.
Yeah.
Olivier, are you okay? You can unmute yourself, everything. Can you hear us?
Sorry, yes, can you hear me?
Yeah.
Yes.
Maite, please, I've sent you my issues have happened again. I've sent you my files on WhatsApp. If you could help me.
Oh, WhatsApp, yeah.
Yes, because I'm on my phone. It's a little bit challenging. I'm on my phone now.
Sure. So this is one.
Is everyone, Olivia, if you're able to share on WhatsApp, and then we can look at it afterwards a little bit, but can we just to see if
I'm sharing for him.
Yeah.
But yes, you can move forward if.
Okay, because maybe this will help anyway with the just see if it's let me share my screen again. So I also cheated really using the program itself to do some of the curve matching, but this is what I came up with, and so in the VES 1, all of them are three layer models. First of all, VES 1 appears to have 2 meters, 2.5 meters of higher conductivity, higher resistivity material, and then 17 meters thickness of this lower conductivity material, perhaps getting to about 20 meters depth before it goes into a very high number for the final layer, which we can assume is the basement rock. With VES 2, very similar picture really. It had a slightly higher resistivity for the top layer and slightly less thickness, but then a depth of 32 meters for the less, which I think was very similar to what you were talking about with your interpretation, Maite, when you described it. Slightly thicker layer of more transmissive material before going into the game of the basement rock. And then for number 3, once corrected, because there were 2 errors in there, we're looking at a 5 meter thickness of more resistive material, then 15 meters of this low conductivity, low resistivity material, high conductivity material, before going into some very crystalline rock again. That could be slightly refined by changing this number at the base, by the way, to maybe go to 10,000 or something like that, so that it's a bit more, realistic to what and more uniform. So we have a uniform number for the three. But out of that, those data sets, what is the most attractive data set, just based on the saturated thickness, has got to be the one that's at 34 meters, almost 35 meters depth, compared to 20 meters depth for VES 3 and roughly 20 meters depth for VES 1. So this VES 2 at 35 meters thickness seems to be the most attractive. So those are the numbers that I pulled out, but I just used the automated green button, basically, to get those results quickly. And I should add that the VES 3, I deliberately modified 2 of the data points to have error, so that we could see those and try and correct those. So I'm not sure what the VES 3 might be different for different people based on the correction that was done. But it was also chosen by the contractor, the VES 2, for the drilling works. And so the borehole was drilled based on that location just outside the hospital. And this is the geology that was encountered ultimately. So we had laterites for about 2 meters depth, which is actually very, very similar to the kind of reading we're getting here for VES 2, just by the automated stuff. Then it went into clays and then saturated sands to a total depth of 26.5 meters. So this appears to have overestimated that to some degree, if we were using this straight up, before going into the granite. But that borehole was drilled successfully with a 6 meter cube per hour production rate. So overall, the survey was a great success, in the sense that a decent yielding borehole was produced that is supplying all the needs for the hospital. So I hope that gives a general oversight through a practical example of how 1D geophysics can be used to identify places for doing the vertical electrical soundings, and then carrying out vertical electrical soundings and how to interpret them and choose perhaps the most attractive vertical electrical sounding for water supply. Now, I don't know what would have happened if they drilled a borehole at VES 1 or VES 3 instead, and how much water. We can never know these things. So but certainly that was one of the more high yielding boreholes in the area. So a good result. Are there any questions on this case study, or on the approach, or anything else that needs to be clarified? And otherwise, I'll open up the floor to sort of any general questions that might have come from this short training today, basically.
No, I think it's just because of the modeling. It's always so sensitive to how you tweak it a bit, which gives this sense, yeah, of if Boris would be here, you are cheating, like he would have said this. So yeah, this sense of, okay, you don't have a lot of control somehow, or you can even have control and tweak the answers that you want to have.
I think, yeah, it's really I think it's one of those because with groundwater, and this is not just with geophysics, we are dealing with a lot of uncertainty all the time, and so what the geophysics is trying to do is improve understanding, improve odds of success, but we have to always bear in mind that when you're, for the 1D geophysics, we're putting in 4 electrodes into the ground, and then we're measuring the current going through quite a large area of rock to get one reading, ultimately one fixed reading that we're then utilizing with lots of other readings to try and plot and understand what's happening in the subsurface. And we went through those different problems that arise through those assumptions, well, through the very nature of carrying out geophysics, which are impacting on the results. So at the end of the day, the geophysics is certainly helping, and in this particular example, it produced a really good result. But we are working with uncertainty. I mean, I think the key thing here was that those 3 VES were carried out, and one result, the VES 2, did show a better result in terms of the depth of potential saturated thickness, and that's why it was chosen. And it probably was the right choice because we had a bit more certainty there than we had elsewhere. And I would go back maybe after this to take another look at those rules that were set up by I've forgotten the company's name off the top of my head, but they're based in Uganda. And take a look at that sheet again and see how they were scoring both the constant separation traversing and then the VES afterwards, and to determine sort of how all of these different aspects of carrying out a survey will give more confidence to the surveyor on the result, because it's about just building confidence based on multiple data. Is actually, you're still looking at the desk study work even when you're interpreting the geophysics. I hope that what this does do today is now when you look at another report that comes through from a geophysical contractor, you know a little bit more about what you should be expecting from them, and also you might reconsider how you might contract them out in the first place potentially. So I hope that, I mean, that's one of the key aims really for today, is to give you that feeling of slight understanding and confidence about dealing with these contractors and their data sets. Yeah. Carmen.
No, that also you think that we should be always on the field supervising all the work, no? As how they are taking the measures and all the things, like to be...
Yeah. So
if it's possible. Or...
I'm not sure how possible it would be to supervise. I mean, I'm sure it's possible in some. I mean, it depends on how you do the contract. Again, if you want to supervising the geophysical survey, then of course that supervisor could be granted the authority to be checking their instrumentation, checking their measurements, checking their contact points with the electrodes, per each measurement, etc. But I think in the general assumption would be that they would get on with it themselves in terms of that. But what you'd want to see from them before they start the work is their field plan, is their survey plan, because they will be charging based on, they'll either be charging on a day rate or they might be charging per what you've requested them to do. Could be another approach. We want to have 4 constant separation traverses across here, and the selection of 4 vertical electrical soundings at the best points within the constant separation traverses to help us to choose the borehole site. rather than the contractor goes out to do a geophysical survey and they come back to you with 3 VES measurements that could be selected at any random location, and it's just then let's find the best one out of those 3, which for me is a far more riskier and less scientific methodology to trying to get to an endpoint compared to doing those traverses first of all.
Thank
So
you.
I guess you will ask them, I mean, the literature review with the conceptual model in order to like the 3 parts, right? I mean, a bit of understanding of the geological context that they know about the area, then the conceptual model that they are thinking where to find the water, and then the plan that
That's
they
right.
have for doing the geophysics.
And it doesn't have to be too onerous. You could simply say, look, we would like, as a pre-stage to the field work, a desk study with a work plan of how you would undertake the survey. I mean, they produced the report anyway afterwards, which has got the desk study element in it. But so what you're really asking them for is that part of the work, which is probably a copy and paste. But what you're really asking for is the work plan based on and whether they've got data already, what's their understanding of the area. Do they have already a good idea about the geology and what they should be looking for?
Totally, yeah. Okay. And then you were mentioning during the presentation at the moment when you were starting showing the curves, like this sort of like, okay, you are trying to always look for a curve like this.
Yeah.
Is there any more of these tips that are so characteristic? Like if you see a curve that does like that, that means that, you know, whatever. Or if you get something else that is with salinity, well, I don't think you can really see much, but
salinity's
it's complicated.
a different kettle of fish. And I think that the curve that bell-shaped curve I've shown you is probably a really classical, you know, if you're seeing something like that within a certain where you've got this 3-layered geological profiling where you've got something more impermeable below, something permeable, which is where you're trying to tap into the water there, and then perhaps an unsaturated zone above, then that's, I guess, why that shape is so important, that 3-layered model shape. And if you're in that kind of environment and you're seeing different shapes outside of that, then that would immediately be more you'd be more uneasy about what's going on, and then you'd have to and looking at geological records for the area will be really useful. You know, it's all part of that desk study again. And if you're working with drilling contractors who are doing this work, they should have drilling records for the area that they can show with the old drilling reports, etc., that they can demonstrate their work with to you on. So. But then if we're looking at geophysics in a different kind of aquifer environment where you have layered sedimentary systems or whatever, then that's a whole different ball game. But then you might not be so worried about the geophysics in the first place, because if it's a sedimentary system, then of course you're not worried so much about a deeper weathering zone in a fracture system in an otherwise untransmissive rock. Yeah, I think I mean in difficult geological environments, we didn't touch on that at all, and that's deliberate. I mean, I think you need to bring in expertise for that. But for this middle road where it's not a sedimentary system, but it's a well-established hydrogeological environment that is easy to detect through geophysics. That's, I think, been the main. You know, that's the thing that can be done with just having an understanding of the geology and having an understanding of the concepts of doing a geophysical survey to pick that out, pick those deeper weathering zones out. So that was the purpose really of today.
I mean, totally, for me, it really fulfilled the purpose. I mean, it was really what I was hoping to get, and it really clarified much more the fear as well that you are looking at something that you have much more criteria about how you are reading it, and you are critic about it, and as well what you said, right, to try to put on the table like, okay, no, show me this plan, show me a little bit before this understanding that I can already make a way to screen between the different tenders that you might have, and even asking that into the tender. So for me, super many thank you. I mean, I can stop the recording now. I mean, yes. I don't know if there's more questions or anything in the background, Olivia.